Hi, my name is Janelle Amador, and I'm going to be talking about how mediums affect sound waves. And the materials I'm going to use is 3 wine glasses and water. Let's begin. So for solids, the molecules are very dense, so they're very close together. And since they're very close together, it will be able to transmit energy of the sound waves very fast. It is the solids is one of the best mediums out of the liquids and gases to pass sound waves fast. So for liquids, the molecules are more farther apart than solids, which means it would take longer for sound waves to travel from molecule to molecule in the liquids, and that will affect the intensity since it will decrease the loudness of the sound waves. So yeah, those are liquid mediums. So for gases, it is even less dense than liquids. So it would take more time for sound waves to travel since sound waves travel through vibrations, and the more the cells are farther apart, so it would take longer for the molecules to get that vibration, like the energy, and yeah, it would take more time for sound waves to travel, and the intensity of the sound will be even lower than liquids. So in cold temperatures, the molecules will be more dense. However, they will have less energy, and since it has very less energy, it has less vibration. And sound waves depend on the vibrations of the molecules for it to travel. And since the molecules don't have since cold temperature molecules don't have the energy for it to travel fast, then it will be very slow. And cold temperatures have low humidity, so it will be more dense in water vapor, making sound waves take longer to travel. However, in hot temperatures, the molecules have a lot of energy, and since they have a lot of energy, they vibrate very fast. So the sound waves will be able to travel from molecule to molecule, since the molecules are constantly bumping to each other, and it will be able to transport the sound waves very fast. And since high temperatures have high humidity, it will be less dense than cold temperatures, and it will make sound waves more faster to travel. Now I'm going to be showing you what I was talking about through my demonstration of 3 wine glasses and water. And yeah, I'm going to be using my finger to make the sound, and I'll explain that too. Here we go. Alright, so for the first wine glass, it has no water. As you can hear it, right now I'm forcing, I'm resonating the wine glass. So I'm going to be forcing the air, I will be forcing the air particles to vibrate as well in the same frequency in the wine glass. And the water, you know, since it has no water, it would develop a higher pitch since the water molecules are not blocking the air particles. So yeah, this is the first wine glass. For the second wine glass, it has a little bit of water. Yeah, and right now I'm going to resonate. I'm going to be forcing to resonate the air particles around the wine glass as well. As you can hear, this has a higher pitch. This has a higher pitch than this one. And yeah, that's basically it. Just I'm forcing the air particles to vibrate at the same frequency as the one I'm making on my finger and the glass. And yeah, this is the second wine glass. For the third one, it has more water than the other two, and because of this more water, it will develop a lower pitch. And I'm going to show you right now. If you can hear it, resonating the wine glass. So I'll make the air particles vibrate the same frequency as well. And that frequency is developing this pitch, this lower pitch. And the amount of water will affect the pitch, since it will take more space in the air. And so here it is. The more air there is in a wine glass, the higher the pitch. Since like all that air is vibrating, it will have a higher pitch. But since there's a few air particles in the wine glass, it's going to develop a lower pitch, since there's not there's more water taking up space. And yeah, that's basically my demonstration. And yeah, that's how I'm showing how. That's how I showed how sound traveled through this. So yeah.